All right, we've seen two examples of substitution. We're now on to the second method, method 2, which is called the addition method, also known as elimination. So you might hear me say both of those. I'm used to saying elimination, actually, so you'll probably hear that more, but I believe your book calls it addition. The reason why it's called the addition method is we get to add the equations together. And the reason why we call it elimination is because our goal is to eliminate or cancel out a variable. There's different strategies for making this happen. So we'll see a couple examples. Notice in this case, none of the variables have a 1 coefficient in front of them. So using substitution would be more difficult for sure. It'd be hard to isolate X or Y in either equation. You could do it, it would just be much more challenging. I personally really like the elimination method or the addition method. We're going to use it quite a bit more, especially when we get to the systems in 3 variables. So this is a great strategy to get used to. Let's take a look at number 1 first. Notice how the variables are lined up with each other already. The X's are kind of stacked on top of each other, and then the Y's are stacked on top of each other. Let's see if we can tell which variable would more easily eliminate or cancel out. Notice that the 3y and the 3y are together. They're sort of stacked together. They're stacked on top of each other. If only we could get one of them to be negative. And here's the good news, we can. We can get one of them to be negative. So what you can do is multiply one of your equations by basically whatever you want. As long as you multiply both sides, you can manipulate equations in this way. It's kind of like dividing both sides by 2 or something. In this case, we can multiply both sides of an equation by -1. So I'm going to start this one by multiplying the second equation by -1 so that we can get that middle term to be -3y instead of +3y, so that it can cancel out with the +3y right above it. So what I'm doing right now is I'm rewriting the first equation as -4x minus 3y equals -26. The first equation can stay as it is, 7x plus 3y equals 32. Then we get to add the equations together. This is the addition part. So when we add the equations together, we'll see that the y cancels out. Plus 3y minus 3y cancel. That's elimination. We've eliminated the y's. Then we combine everything else. 7x minus 4x would be 3x. 32 minus 26 is 6. Then we just finish solving for x, divide by 3, we get x equals 2. From here to the end of the problem, it's really similar to our last examples where you just substitute whatever you got for your variable, you substitute it back into one of the original equations and then solve for the other variable. So you can pick whichever equation looks easier. I'm going to go with the second one just because the numbers are smaller. So 4x plus 3y equals 26. I'm replacing x with 2. Then we can work on solving for y. 4 times 2 is 8. So 8 plus 3y equals 26. I would subtract 8 on both sides and get 3y equals 18. And then divide by 3 and we get y equals 6. So the solution that we just got is 2, 6. Now in terms of checking, here's what I would recommend when you're using elimination. You really don't need to check in both equations because you just used one of them to get your solution. So if you want to check in that one, it's fine. It's just that it's going to be a little bit redundant with what you just did. So the more important equation to check is the one you did not recently use. So we just used the equation that starts with the 4. We don't need to really check in that one because we just used it. Let's check in the first one to be extra sure. So I'm going to do some erasing and make some space. Okay, and my little white rectangle got erased here. I'll put it back. Okay, so while I'm doing that, you can go ahead and start plugging in to the first equation to check our answer. All right, here we go. So I'm checking. So check. We're checking in the first equation. So 7x plus 3y equals 32. Replace x with 2 and y with 6 because those are the solutions that we got. And then we need to check and see if this is a true equation. 7 times 2 is 14. 3 times 6 is 18. 14 plus 18 is 32. Yes, it checks out. 32 equals 32. So that was an example of elimination. In that problem, we eliminated the y's. We'll see some harder examples where we can eliminate x, or when we have to do more multiplying other than just multiplying by -1. Sometimes you'll need to multiply both equations. So for example, in this problem, if we did want to eliminate x, it would be harder. If you notice the 7 and the 4, think of it like getting a common denominator. If you look for a common multiple of 7 and 4, 7 times 4 is 28. What you could do is change both of those coefficients to 28, make one of them positive 28 and the other one negative 28. And then the positive 28x and the negative 28x could cancel. That would take more work, but you could do it by multiplying the first equation by 4 and the second one by 7 or -7. So anyway, it's definitely possible to eliminate any of the variables, either of the variables that you want to, but usually there's going to be an option that's maybe a little easier than another. All right, so that was number 1. Then we'll go ahead and try number 2.